We have a reflection over the x-axis, and we have a change in our period, okay? All those things are important to note because we're gonna have to identify all pieces of this. Okay, the things that are affecting your range are going to be your vertical translation and your amplitude, the change in your amplitude. Amplitude, it helps if I finish writing the word out, barely. Amplitude, okay? So first, the graph of y equals 3 minus 2. 3 minus 2 cosine 3x is the same as y equals negative 2 cosine 3x, vertically translated 3 units up. So it's the same graph, just shuffle 3 units up. Uh-oh, I don't want you to see those yet. So we're going to first figure out what does that put our range at, right? So normally the range of a cosine function, so cosine of x, the range is from -1 to 1, right? Now for cosine x, we have an amplitude of 2 and we're transitioning up 3. So for this function that we're given for this y value, to each one of our values, for -1, we are multiplying it by 2, and we are going up 3. Okay? Then on the other side, we're going to now multiply 1 times 2, and we're going to add 3. So it's going to establish our new max and min values. Okay? So that's what we're doing. We're establishing what are our new max and min values for our interval. Okay? This also is going to affect our intercepts, our x-intercepts as we keep going, but just establishing our range for now. So our range now is going to be from -1 times 2 is -2. -2 plus 3 is going to put us at 1. 1 times 2 is 2. 2 plus 3 is 5. So our range for this function is 1 to 5. That's applying our amplitude and applying our transformation, our vertical transformation, okay? Next, we're going to find our intervals. So our intervals where our function, so keeping in mind again, we're going to be setting up. Okay, so back to what I was saying. So now we're going to find our key points in talk about our period. So we know that our period here is 2 pi over 3. Remember, it's whatever your b value is here. It helps you find your period. So we know our period is 2 pi over 3. Okay, we also can figure that out by taking our original, so creating our inequalities. That's why we're originally 0 less than or equal to, and now it's 3x, right? Less than or equal to 2 pi. This is going to be the fastest way if you forget just any rules, just setting it up. What do I need to do to get x by itself? Divide by 3, divide by 3. And so now we know that our domain for this period, like this piece of the sine graph, because the domain of the entire thing is infinite. But for this little piece here, we're looking at from 0 to 2 pi over 3. Okay. And now we're going to find our important values. We're going to find our halfway points. As you're doing it, sometimes it's helpful to create the table. So as you saw before, so we're going to find our x's. So to find our new x's, we know we start at 0. We got to find the halfway point between 0 and 2 pi over 3. So we're going to find the halfway point between that, and then we're going to establish what the y values would be. Okay. So I'm going to click on my calculator. So if I just was like, I don't know what the halfway point is, that's okay. I'm going to go over here. I'm going to do 2/3 divided by 2. Math, enter. And I get 1/3. So my halfway point is going to be at pi over 3. So this is pi over 3. And I'm going to find the halfway point between 0 and pi over 3. So I'm going to divide that by 2. And I get 1/6. So we get pi over 6. So we now have pi over 6. I'm going to have to find the halfway point between pi over 3 and 2 pi over 3. So I'm going to do 1/3 plus 2/3 divided by 2, math, enter, enter. And we get a half. So we get pi over 2. Okay, so at these points are my critical points. I'm going to label what they are. So I know that if it's a negative 2 as my amplitude, well, before the absolute value to find my amplitude, my A value is negative. That means that instead of starting off as a max, this is going to start off as a min. This would have been where my x-intercept was, but because of that vertical shift, this is not my x-intercept. It's going to be the x-intercept plus your vertical shift. So plus that 3. Does that make sense? And then here's my max. Again, my x-intercept plus 3, and then my min. Okay, so we've already established what our domain and range, our domain is, and our range for this function is 1, 2, 5. So my minimum value is 1, my max is 5. So when I look here, I have my minimum is going to be 1, my max is 5, my minimum is 1. To find your pi over 6, it's your x-intercept, which would have been 0 plus 3. 0 plus 3 is 3. 0 plus 3 is 3. So my points on my graph that are my key points are 0, 1, pi over 6, 3, pi over 3, 5, pi over 2, 3, and then 2 pi over 3, 1. All right, so let's go look at it. All right, so now notice I have those points, right? We're at 1, 3, 5, 3, 1. Okay, now it says to graph a second shift. So to graph a second shift, you're either going to go to the left or to the right. It doesn't really matter which one you go, but knowing what your period is. So our period for this problem, period, equal 2 pi over 3. If I'm going to go to the left, like I did here, that means that I'm now going to go from 0, so where x is 0, and subtract 2 pi over 3. So I'm going to repeat this pattern from 0 to negative 2 pi over 3. And that's why these points are here. Okay? Or if it had said I didn't have to go to the left, I could have went to the right. So I would have added 2 pi over 3 here. So then this graph would have repeated, draw it out a little bit, over here at 4 pi over 3. So I would have repeated the same splits, and then I would have repeated the pattern. I think I went out a little too far, but yeah. You get what I'm saying. I would repeat the pattern going this way. So it would go, again, this is not drawn to scale at all. So, all right. So whether when it says to repeat or sketch, you just got to decide, are you going to go to the left or are you going to go to the right? If you're going to the left, then you're going to the beginning of the cycle we were at and you're subtracting. If you're going to go to the right, you're going to go to the end of the cycle we're at and you're going to add your period. Okay. All right. So I printed out these notes for you and it goes through the steps of us figuring out our interval. So for method 1 is my preferred method. By all means, find the interval whose length is 1 period, which is 2 pi divided by your b. Okay. To do that, you're going to just set up your inequality and get your x by itself. So you set up the inequality, get your x by itself, and then you'll have your beginning and your ending of that piece, that period, that 1 period. Okay, step 2 is to divide it into the 4 parts by finding your averages, your halfway points. Then you're going to evaluate the function for each of the 5 x values, okay? Identifying your max, your min, and where your intercepts would be, and including those shifts. Plot 4 is you would plot the points and making sure that your amplitude is correct. It is 3 or 2 or whatever, however far from the halfway. And then draw additional points as needed. So whether you're going to add or subtract onto there, okay? Step Method 2 is you're going to graph the original parent function a sine b of x, and then you apply the translation. So whether it's going left, right, up, or down, and then apply your, whether it's going left or right, up or down. So this is a graphical method. All right, so we now have a value for everything. So looking here, we have -1 plus 2 sine 4x plus pi over 2 periods. Things we're going to pay attention to is our vertical translation is -1. So instead of adding, we are subtracting. Our a value here is +2. So our snake is going to start with a max and with a min. Okay. We have 4x plus pi. That means that our period is changing from 2 pi. It's going to be smaller. And it wants us to create 2 periods here. Okay. So we're going to go through these parts with the sine function. Hold on for a second. All right. So we now have all of our variables. We have A, B, C, and D. So with A, B, C, and D, your C is going to be your vertical translation. Your A is going to help you determine whether it's a positive or negative, and if the value of your amplitude, if it's more than 1 or less than 1. Your B is what tells you your period, helps you find your period, and your D is going to be your horizontal translation. Notice right here that in order for you to know the value of your D, your B has to be factored out, okay? So up first, we have y equals -1 plus 2 sine of 4x plus pi over 2 periods is what they want us to graph. The first thing we're going to do is factor out the 4 so that we have our B and our D completely separated. So I factor out the 4. 4x divided by 4 is x. Pi divided by 4 is pi over 4. So now I clearly have all of my pieces. Here is my C, here is my A, here is my B, and here is my D. Every piece plays a role, okay? Because every piece plays a role, I can describe this function before even graphing it. I know that it is on a period of pi over 2. I know that it was shifted horizontally to the left by pi over 4. I know that my amplitude is 2. And I now know that because my amplitude is 2, I then have a vertical translation, and that vertical translation is going to move it up or down. Well, in this case, it's going to move it down. Okay. So we're going to find our interval. At this point, I feel like we can find our interval just fine, right? We can find the interval. You're confident, right? Okay. You're good with the interval. So my intervals would be, would figure it out, taking this, setting in the middle, getting x by itself. So we're going to divide by 4, then subtract pi over 4. And we end up with negative pi over 4 to pi over 4. Okay. Once we have our interval, we then can find our key points, right? Our key points by creating our 4 sections. So to divide the interval into 4 equal parts, we're going to end up with these values. Find the halfway, which is at 0. Find the halfway, which is at negative pi over 8, which is at positive pi over 8. Okay, so now we have those values. Now we're going to make our table of our values. So when we make our table, it's going to end up being, here we go. So we have our x's. Our first x is at negative pi over 4. I don't know why I'm drawing sideways. We're just going to go with it. Negative pi over 8. We're at 0. We're at pi over 8. And we're at pi over 4. Okay, so our x's are done. Our y's are what we got to figure out what happened to our y's. Okay, normally our y's before any transformation. So our parent function, the cosine of, it's not cosine, it's sine. Sine sine of x, it would normally be 0, then 1, then we would be at 0, then -1, and then 0. That's sine x. However, we had changed to our function, and that change to our function was our value going up and being multiplied, correct? Yes, correct, Ms. Jones. So that change means that to each one of our y values, what's going to take place? Well, let me go back and look at it. So to each one of our y values, we're multiplying by 2 and we are subtracting 1. So we're going to multiply by 2 and subtract 1. So to find my new y's are going to take sine of x, and we're going to multiply sine of x and subtract 1. So 0 times 2 is 0. 0 minus 1 is -1. 1 times 2 is 2. 2 minus 1 is 1. 0 times 2 is 0. 0 minus 1 is -1. Sorry. 2 times -1 is -2. -2 minus 1 is -3. And then 0 is going to also be -1. So these are your points now. Because we now applied our amplitude and our vertical translation. Okay, so this is going to always be your A. So we have our A times whatever our original Y was, plus our C, whatever our C is, okay? And that's how I end up with my new points. So negative pi over 4 is at -1. Negative pi over 8 is at 1. 0 is at -1. Pi over 8 is at -3. Pi over 4 is at -1. So you go look at it. Oh my gosh. There it is, smack dab in the middle. Okay. To do another curve, remember, either you're going to go to the left or you're going to go to the right. If you're going to the right, you're going to be adding your pi half, or to the left, you would be subtracting. You also can just do a little bit of both and have a full curve. It's just half here and half there. I don't count this as a full shift, but as a full phase, but apparently they do. It's making sure you identify all the parts, okay?